All right, whenever you're ready.
Okay. I can go ahead and get started then. So, got it. With Dave Young, with HP/Teradici, we will be talking to you guys about our remote access solution and software and solutions around Zero Trust. I wanted to first thank the ATARC team for inviting us here for this event. And it's been a pleasure. Got the chance to meet a few of the folks at a couple of events recently. So that's been very, very enjoyable. Can everybody hear me? Sound check. So sounds good.
Yep, you're good.
So I'm just doing a quick I'm going to do a quick introduction on Teradici, and then I'm going to turn over to Dave, who's going to do the bulk of the presentation and the use cases. So for those who don't know who Teradici is, Teradici's been around since 2004. We've founded out of Vancouver, British Columbia. We help customers or those who have a need to deliver their workstations via a multi-codec protocol solution that captures the remote workstation and transmits that to the user wherever they're sitting at from multiple different devices. We've been doing this for a very long time. We have a lot of partnerships with the likes of, HP, Dell, VMware, Amazon, Microsoft, all the different providers out there. We've been doing this since 2013. We had lots of integrations with VMware directly, also Amazon Workspaces. Fast forward to today, just recently, HP Inc. or HPI acquired Teradici last year, so now we are an HP company, software company inside of HP. And in 2020 is when Teradici first introduced their direction to move into a zero trust architecture. And that's what we are going to not talk too much because that's still in the works, but we at least started to announce that as Teradici moves from just being a protocol and zero clients to moving more into software. So I'm going to pause right there to see if anyone has any questions in regard to the history of Teradici, because I want to let Dave get into the details and what this means to you guys. So any questions on background on Teradici, history, where we at, things like that. Standard 3 seconds. I'm going to say no. So here I'm going to introduce Dave. I'll let you do the bulk of the presentation.
Awesome. Thank you much. So I'm going to start with, while you guys are kind of looking through the agenda, a little my background. Spent 10 years in the Navy on the submarine side of the world and ended my time in Seattle, where I was one of the senior watch officers out there for PAC fleet operations. And this is where I got introduced to my first zero client. So oddly enough, it was a machine that we had a bunch of data on that we didn't want out on the general access area. We wanted to make sure it stayed locked up. So we literally took a safe, drilled a hole in it, put the machine in it, ran some fiber out to a workstation that had what was called a Novell boot prom, which allowed us to remotely boot into the server. And often only went no data at rest, right? And as we start to talk about that, the industry has went through a lot of things. We're going to talk about data first, right? I'm not going to name any agencies. We'll protect the innocent, but we need to do a lot of thinking about what do we do with data, right? When we're in the SCIF or on-prem, right? Data on the desktop, laptop is not a big deal, right? It's all there. The building is secured. We maintain controls, right? Data shouldn't leave the building. We don't have to worry about my social security number.
Okay.
And I think there's somebody with a question.
Keep my eye out to see what shows up.
Nope, sorry about
Haley,
that.
if you can hit, no worries. If you can hit the mute for that person, he probably didn't realize it came on. So as we start to look at all this data, right? Data in multiple locations means that we have to protect multiple things. We all remember the days of degals and hard drives. I remember the days of grinding them, right? Literally breaking them open and grinding them. And as we start to think about that, now's the time to start changing what we do, right? One of the things that we're stuck with is, hey, with COVID, people are going home to work, right? So now that data is at rest on a device that is not on-prem. And as we think about that, given, and I'll give you my background, I'm a cryptologist, right? Given time and CPU cycles, anything is breakable, right? And as we start to look at that, now we have devices that we do not have physical control over. That means that data could potentially be compromised. I think there's somebody in the news right now that took their laptop in to get worked on, and there were some embarrassing things on there. So as we start to think about that, as agencies and organizations, we want to protect that data that is out in the wild on the edge, right? And I call that data at rest, right? Literal files, right? So as we start to think about how do we want to re-architect and address this, it's some simple moving of things around. Let's move that machine back into the premises, right? And remotely control it out in the wild. So now if I'm on-prem, I'm at the physical machine. I could not be at the physical machine either. I could be at the virtual machine, right? And then I come through the firewall and connect, and the only things that we're sending back and forth now are pixels. So let's take, we'll take Tiddlywinks organization's payroll file. I'm busily working on payroll, got to have it done, take my laptop home, leave it on the train. Somebody gets a hold of it, they crack the file, and now they have my organization's payroll information, which may have a whole lot of people's social security and PII information, right? So now we have compromised, and we're just a small organization, only 200,000 employees, right? So now we've compromised 200,000 employees' data. If we change that around and we're only sending the pixels, hey, I left my device on the train, there's nothing to be gained, right? All that data when power's off is gone, right? If I was sitting at the desk and I walked out of the room and there was some information there, it would only be the information that was what I was actually looking at on the screen. So instead of 200,000 records, maybe it's 20 records, maybe it's 2 records, right? So our impact of data leakage starts to change. And this is a very simple change that we can implement by just re-architecting what we can do. And as we start to talk about zero trust, and the things that we're doing there, this gives us an even bigger opportunity to protect the attack vectors, right? We'll talk more about that a little bit later, but I want to jump into kind of what are our customers and why, right? So you'll hear me often say fidelity, right? It's all about fidelity, meaning if it doesn't look real, it doesn't look like I would expect it if I had a physical machine, then the user is going to know that something is different, right? And maybe that's blurring, et cetera, et cetera. So as we start to look at fidelity, right, this is a huge thing. Teradici is very well known in the gaming and M&E environments, okay? Now, in my years of government work, I don't think I've played one game on my PC, unless you count solitaire when I was bored on a plane, right? And I don't think you need to have high definition video for solitaire. So as we start to look at this importance around fidelity, right? Let's apply that to a couple different scenarios. Maybe I'm looking at financial trading information and I want to see the spikes and the peaks and all that good stuff. Every pixel that is presented must be represented. If I'm in a healthcare environment, this is a personal story. I had to go in and have an MRI done because I was having some back pain. Apparently back pain can be associated with some kind of cancer, and they wanted to make sure they didn't have cancer going on, right? Good news is no cancer, just pulled my back. As you look at those pixels, one little hidden pixel could be the difference between early detection and no detection, right? So we want to make sure that what's presented is represented and vice versa. So fidelity is very, very important. Broadcasting, right? We got 4K video running out there, right? And if you can't make sure all those pixels are perfect and represented in the location and the color that they are, you're going to have things that seem off. Okay, or they're going to be blurred, right? That one little pixel is blurred out. Instead of being white in the middle of a screen of gray, it's going to be blurred into gray and nobody's going to notice that change. So as we start to look at all that stuff, fidelity is very, very important. Fidelity in the government, right? We build things, we model things, we Google Earth things, we imagery things, all that good stuff. If we're looking for bad guys, right, we want to make sure that the image that we're looking at is 100% representative of what we took, right? So make sure that it doesn't blur out the mustache or doesn't blur out this, doesn't blur out that. I wish it would blur some hair on the top of my head, but it won't do that. Maybe on a different protocol. So as we start to look at all that stuff, that becomes very, very important. In the government space, we're very well known for our protocol and the security that it brings to it. We've been often known as just a hardware company. We're going to talk a little bit about that, but let's talk about the PCoIP technology. So the technology is our transport protocol, that allows us to take from the source, we'll call that the virtual machine or the physical machine, and send it to where the user sits. Okay, and ultimately at a very high level, what we're doing is we're sending some algorithms down the line and say, paint these pixels, right? So if we look at this screen, I'm just going to touch the high ones. We got some black, we got some blue, and we got some white on this, right? We're going to send down an algorithm that says, hey, paint these pixels in these locations, these colors, right? And if nothing changes, I don't have to update anything, right? Now, if I advance a screen, and I'll do that, and then come back, we may have enough cache in there that we don't have to retransmit all that data, right? So it becomes very, very efficient as we start to look at painting that screen for that user. And let's just say I'm sitting here doing nothing. The amount of bandwidth that we're utilizing for this screen to sit here is very, very low. We may send some clock updates, we may send some mouse updates, right? Things like that. But the overall data that we have to send down the line is very, very small. So as we start to look at that, we can do some really cool things. I've got customers in the gov space that do things over satellite links, right? And we all know that satellite links aren't so great unless you're using something like low orbit, right? Because of the time and the latency. But to be able to take and see data across legacy satellite links is pretty impressive when we think about some of the challenges that we have as far as latency and bandwidth and all that good stuff. So all these packets that we send down the wire are encrypted. Okay, and we'll talk about encryption a little bit later, but ultimately what that means is that data, okay, that's in motion is protected, right? Now, I am not advocating that anybody violate any of NSA's guidance, okay, about outer tunnels and inner tunnels, and if you know what I'm talking about, we can always sync up later on that. But ultimately, from a normal user perspective, right, where we don't have to worry about outer tunnels and inner tunnels, this tunnel of data is encrypted, and it protects us from having somebody gather these packets and reassemble the screen on the fly. Okay, so it gives us that capability to kind of protect that data while it's in motion. Let's talk about some of the things you may not know. Right, there's a lot of things that we're known for. Zero clients, right? Things that we may not be known for is the fact that we have a lot of clients. We're going to talk deeply about those, but we have different things: iPad, Android, Mac, Windows, Linux, thin clients, right? Different manufacturers have integrated our client into these devices so they can do different things. We have what we call CAD Manager. We'll hit that in depth here shortly, but that gives us the ability to do things on-prem, hybrid, right? Let's go multiple clouds, right? Or maybe I want to go on-prem and cloud, right? We could do that. It gives us the ability to go cross-cloud, multi-cloud, and even dark site. Right, we've got a lot of customers that, hey, I don't need my data leaving the site of the data center, and it's a disconnected site. We can support that too. Okay, flexibility, right? We really don't care what the hypervisor is. Now, there's some ability to that, right? You can't go do something totally crazy, but standard off-the-shelf stuff, as long as it will run a Windows, Linux, or Mac OS VM, we can start to utilize that infrastructure to build out virtual machines so that you can connect to them. And then last but not least, we are not virtual bound, right? A lot of our customers use it for physical, right? During the pandemic, we came up with a work from home solution. Literally install the agent onto that machine and connect to it from home. I'm actually doing that right now from a dumb client to my Mac OS client. Okay, so I'm going across the room and remotely controlling my Mac OS. We also have the ability to support multiple enclaves, right? Let me back up one. Let's talk about density. Density is really, really important, especially as we start to look at VDI. As we look at VDI, being able to address the capability of making sure that I'm getting the maximum dollar per CPU cycle is very, very important. And going down the path of optimizing everything with the newer agents, we're able to get higher and higher density. So it gives us that capability to maximize that return on investment. Secure, right? As you start to look at this, it's easy, it's secure. You're able to put everything in the data center. We have, certificates that are involved so that we can make sure all that communication is good to go, right? Future proofing, we're going to really hit this here in a second, but going to what's coming next, right? You may not have a need to do 2 monitors 4K display today, but next week you might, right? Depending on the workload, right? So as you start to go down that path, we're giving you a path that you can grow into, not have to adopt immediately. Persona management, we don't really care. Use whatever you want, whatever seems to solve your problem. We're not really tied to anything. There's a lot of cool things out there that you can utilize, right? And then we'll talk about high video graphics and being able to do things around AVX2 offloads. So let's kind of take a look at the security posture when it comes from edge devices, right? In my mind, the most insecure device that you can access is a machine with a hard drive that somebody can physically gain access to, that has data, files, et cetera, on there, okay? Where I could install something kind of Trojan-esque, where I can, bleed off information and be able to gather data, right? As we go to the left and we look at the different thin clients, they meet a niche where maybe you don't get security, right? You need lesser security. And then we go to the Tera 2 Zero client. And the Tera 2 Zero client gives us the capability to remove all that data at rest, right? It's very purpose-built. We're not installing any tools, games, keystroke loggers, et cetera, because the user just has no capability to do that, nor does the admin, right? It is very purpose-built to do one thing: connect to a broker or to an agent so that we can then send pixels across the wire. And then last but not least, the most secure is our next generation Zero client, which is where we started this whole zero trust architecture, roughly in 2020. Arn, one of our product managers, is on the phone. He probably started dreaming this up many years before that, but finally got the execution of it in around 2020. And this is going to give us the capability to establish that zero trust architecture where, hey, that device is out there. I don't know if it's been tampered with. I don't know where it came from. So therefore, I don't trust it. And as we deal with that, it gives us a greater sense of security and a greater implementation around security. So let's talk a little bit about that zero trust architecture and what we're doing, right? So the next gen, as we like to call it, Zero client, is going to be integrated in with our zero trust architecture. So basically, you're going to be able to put a certificate on this device, know that it hasn't been tampered with, allow that device to do certain things, okay? Bringing it into your environment, knowing that it is in a good state, okay? And as we start to do that, depending on what you do, right, you may be pointing this at Horizon View, Cloud Access, our CAD software. You may be pointing at Amazon, right? You may be pointing it at some of our other partners, right? They're doing different things. So it gives you that capability to integrate this as you're going forward so that you can make sure that that infrastructure is secure when we bring the user in, whether it's on-prem or remote. So let's talk a little bit about the CAD solution, okay? CAD solution is our entry into brokering, right? Now, it's very important that I point out brokering is not specifically virtual. It could be physical, like I'm doing with my Mac. It could be going to a high-end workstation that we do 3D modeling on that I want to keep in the data center. I just saw from the HPI side, there's a machine that costs several $1,000s, right? We don't want that sitting underneath my desk where I may spill my coffee on it. We want to move that into the data center and then remotely compute to it, giving us the capability to connect the user, manage the resource, and give them access to the machine without them knowing. So as we talk about CAS, most important thing I need to point out as we go forward is we had some of the best marketing people in the world. They followed the cloud trend. Everything had to have the word cloud in front of it. And yes, we do have a cloud hosted version of this, but we also have a standalone on-prem version. So as you start to look at what your solution needs, you may say, cloud's good for me. You may say, no, I want it in my own private enclave where only I have access to that CAS information. So it will run standalone. So let's take a quick look at some of the architecture, right? So many of you on this call may already be running 0 clients, right, connecting to Horizon View. And that's a fine solution. We do not mind that solution, right? It does what it needs to do. It's generally around task workers and knowledge workers that we deploy that solution. We also can take that same 0 client and point it at workspaces on Amazon, right? So if that's what you need to do, you want 0 data at rest, you want to point it at AWS, great, not a problem, you can do that. We also have our CAS client, or a client, excuse me, where we can say, hey, I want to run it on laptop, tablet, whatever I so choose, and point those at multiple different things. We're pretty agnostic as to what we can point that at. You know, GCP, Azure, AWS, no problems, right? I'm working with a customer that has their own private offering of a cloud, right? They're putting together all the work for the security. And as we start to look at that, right, it doesn't really matter to us. What do you want to do on the infrastructure? Hey, that's up to you. If you want to run hyper-converged or you want to run standalone systems, that is a fine thing to go ahead and do. It's just a matter of, does it support Windows, Linux, and Mac OS if you so desire to go down that path. So as we start to look at all this, that becomes a very flexible solution that we can deploy and solve problems with. All right, so let's look at all the different components, and then we'll start to get into some of the zero trust discussion. So there's a whole bunch of components that we have. I just want to identify them. They're clients. That is where the user sits. Windows, Linux, Mac, Android, and iOS are all different clients we can have. We then connect on the back end to our agent, right? Once again, physical or virtual, Windows, Mac, Linux, okay? And then we have a couple different infrastructure components. We have our management console right now that's used to manage those 0 clients. We'll be introducing our zero trust framework stuff, which will allow us to go down that zero trust path, right? And do different things. So that will do all of our certificate management and enablement of that infrastructure. We then have, going to number 4, sorry, I got to get where I'm at, our cloud access connector. What that allows us to do is put a purpose-built VPN or proxy server into the DMZ and bring our users in through that device, and only that communication is allowed. We're not going to allow file transfers through it. It's all PCoIP traffic, so that we can build that and optimize that without putting a huge load on other VPN type resources. And then last but not least is the connection manager, CMSG, or as we call it, CAS manager, okay? That gives us the capability to do all of our rules, entitlements, et cetera, et cetera. So if I want to connect Dave Young to a Windows and a Linux machine, we put those pools together, we entitle him to that pool, and then when I shake the mouse and go to connect, I get given some options. Okay, so those are all the major components. I want to pause for just a moment before we go any further to see if there's any questions on those components. Don't be afraid. I won't make fun of you for asking. All right, we'll keep moving. So just another way of looking at this, just so you can take a higher level view on it, right? What this gives us the capability to do is have multiple different scenarios that we support. Maybe it's on-prem, maybe it's remote users working from home, maybe it's contractors, right, that are on-prem, off-prem, it doesn't really matter. We bring them through to the same infrastructure. Now on the back end, we may want to logically separate it, right? But we bring them through to that infrastructure so that we can build that up and utilize that and have it in our environment, right? So all of our data sits in, whether it's our 4 physical walls or maybe it's the walls of a virtual cloud, right? That we're able to set that in. And it gives us that capability to use different solutions. Maybe with contractors, you want them to bring their own device, right? Yet we don't trust that device fully. So we want to be able to put rules in place on it and protect that data that's being transmitted to that device so that we can make sure it doesn't end up as a file on their hard drive. So a lot of different things that we can do in order to solve these different problems that we want to go forward with. So a little of the why Teradici and Federal, right? Fidelity, right? User experience, right? Getting up to 60 frames per second if you so desire. Now, as we start to look at that, 60 frames per second with 3D graphics and things like that, you have to design on both ends of that. So this is not a design discussion. This is a security and experience discussion, right? Being able to remote and only send those pixels. I've said this several times, but I just want to make sure I reiterate that. Those pixels are only what's being painted to the screen, okay? It is not the data, the physical data file that is being sent, right? So it changes what we're doing, right? Keeping that data in your data center, right? You can do BYOD, right? And all the different things around bring your own device that you want to do, or used all over the place, right? DOE, Air Force, Navy, Marine Corps, NSA, Joint Staff, Pentagon, just all sorts of different commands and agencies. Department of Justice uses a ton of us for different things. So as we start to look at that, that changes, you know, hey, who's doing what? How can we kind of adopt this and integrate it into our journey? Okay. Once again, you can come from Mac, Linux, workstations, Windows desktops, et cetera, Chromebooks, thin clients, you know, you name it, we can pretty much support it, okay? Smart card support at different levels, depending on what you're doing, we're able to integrate in that. I read a great, I think we may be into what I call the post-PIV, post-smart card days. Agencies are starting to look at going PIV-less or CAC-less and being able to do different things. So as we start to look at that, you know, the world's your oyster. How do you want to build this out and design it? Well, you just got to put all the right components together. I want to hit this because it's an important one. I have a lot of customers that are down a certain path and their workloads don't perform as the desire, right? And bringing CAS into the mix of those environments allows us to start to say, hey, I've got a heavy end workload that doesn't perform under solution X, and I want to run it under solution Y. Well, you can run those together, right, side by side, and take those high-end workloads and move them somewhere else so that you can optimize your infrastructure, okay? And then last but not least, FIPS 140-2, right? We've submitted everything to the lab. For the zero clients, that's all being done, and we're just waiting for the labs to get finished. Aaron can probably attest, this has been the longest cycle. I'm not sure what's going on with the labs, but since COVID, you know, the amount of output seems to be very much hindered because previous times this went fairly fast. We're just still waiting on that final validation that they need to complete, but everything's been submitted and is in their hands. So let's start talking about, there was a whole bunch of different scenarios, and I kind of want to go through those and open this for discussion so people can ask questions. So the first scenario, Central HQ, right? Very large CONUS headquarters location. And the scenario that we're given is good connectivity. Users are coming from GFE equipment, right? Perimeters defined, and they're accessing data both on-prem and in the cloud, right? So how we fit into this is you can do a couple different things. Maybe that GFE equipment is high-end GFE equipment. Move that into the data center, remote them to it, put those zero clients or thinner clients, and maybe it's the next gen client, into a very protected network, right? No holes out except for to get to those virtual machines. So I'd come through the concentrator, or the CAC as we call it, and allow them to send those pixels back and forth. Benefits that you get out of this is the data's in the data center, right? You got a very secure zone that the users can access from, right? And we've reduced the amount of data at rest at the edge, right? So let's just say we're in a open workspace, right? Where, you know, we have controlled access to it, but people walk through. The amount of data that would be accessible by people walking through is severely limited because somebody couldn't pick up a laptop and put it in their coat and walk away with it, right? So it gives us that ability to protect that data. And then last but not least, and this is sometimes the hidden benefit, is moving the user's access to data closer, right? I remember my first, was it Metaframe or WinFrame? I don't remember which one came first, chicken or the egg, Citrix deployment many years ago, right? And ultimately it was about being able to bring users into the data center, okay? And by bringing users into the data center, we could get them closer to the data, okay? And by getting closer to the data, that chatter back and forth was optimized, right? We weren't going over WAN links, we were going over LAN links, and that gave us the ability to have that data go back and forth very fast and enhance the user experience. And then all we sent was the refreshes of, hey, here's your Excel report that you just ran. You didn't realize it, but there's 30 megs of data in the background that went back and forth for me to present you with 300K worth of data. So moving that user closer to the data is very important. I see there was a question. Oh, no, Aaron was just adding some information and a link to NIST for validation. So you guys are more than happy to check that out if you so desire. Any questions on this use case that anybody has? I'll give it the obligatory 5 seconds. All right, let's move on to another use case, right? Satellite office, good connectivity, right? But these are located all over the world, right? Could be CONUS or out CONUS. Size of staff varies, right? I think we all have experienced these things. Good connectivity. They operate GFE equipment on a defined network, right? And they access both on-prem, so it could be out of CONUS on-prem data, to headquarters data and data in the cloud. So as we start to look at this, how does the Teradici CAD solution with Zero Trust play into this, right? Well, we can change the data path once again, right? I can put a fairly, what I call dumb device at the desk, and the user can say, hey, I'm accessing local resources. Next 5 minutes later, I need to go access something that sits in the cloud. Maybe we want to do that by a separate virtual machine, right? So I go and transport my data processing. I'm into the cloud now, and all I'm sending back and forth is pixels. And then later, I might need to do something on-prem CONUS, right, at HQ. So I could make a separate connection to that, right? Doing all these things allows us to really control what the user experience is going to look like, right? I'm able to then go forward and say, hey, just by picking a different desktop, I can now be in a different environment. And that gives us the capability to enhance that user experience. Some of the things that we get to do, right? We get to expand easily, right? If you look at your user's performance profile, you can pretty much guess what it's going to look like in the future, right? So let's just say I have one user, it's a high graphics user. I'm just going to make up some number. They push 3 megs of data per second, and I need to add 10 more of those, right? Well, okay, I need to go from 3 megs per second to 3 times 10 is 30 megs per second. So that's a bandwidth I need to guess on. It would probably end up being less because deduplication and all that good stuff, but it gives us the capability to say, hey, I know what I need, right? Versus what we had in the past, which is, well, if everybody grabs the same file at the same time in the morning, I now have a huge problem, right? So it gives us a more predictable experience as far as the user is concerned. We're removing that data at rest, right, from the GFE equipment, right, so that we can increase our security posture, right? Less data that we have sitting on the device, the better off we are, especially when it comes to sensitive data, okay? Hybrid design, right? We can use the rules within CAS to be able to say, hey, connect to here, right? You're on-prem, connect to here, you're off-prem, and we're going to be sending pixels back and forth. It may be a higher latency experience, but still probably unnoticeable to the end user. And then last but not least, you might do a hub and spoke type design where, hey, I don't want the users, site's large enough. I don't want all those users for their local stuff coming across the wire. So I might deploy some resources into a local on-prem solution. And then last but not least, being able to quickly move from different types of scenarios without actually changing equipment, right? I can go from on-prem to off-prem and I'm still sitting in the same keyboard, video, mouse infrastructure that I had before. Any questions on the satellite office solution? All right, we'll move on to bandwidth challenge, right? By being able to change data flow, right? What we're able to do is predict what kind of bandwidth we need, and that gives us the capability to go forward and say, hey, I now have X amount of traffic that I need to address, and my bandwidth supports that. And I can then have a reliable connection into the data center where I can move large files around, et cetera, right? So reducing the path to the data by putting remote controlling PCoIP technology into play. This is one that we see often where we don't want to have a lot of data. I see it in the DoD, no data in the field, right? So how do we limit how much data we have in the field? By doing this satellite type support, right? We're able to remove the amount of data sitting at the edge. Pause on this one for just a few seconds, just to see if there's any questions. All right, we're going to move on to using applications. Let's see, remote user accessing corporate applications and data using government issued device, right? Ultimately, it's once again, put the device in the data center, right? Whether that's physical or virtual, remote control to it using PCoIP and a client, right? So now we've got the data in a secure zone, right? We're able to know where it's at, physically isolated, et cetera, and then from a user's perspective, you know, how do they want to access it, right? Maybe I'm sitting in a kiosk doing work and I'm doing it from my iPad, right? Maybe it's from a laptop, maybe it's from my iPhone and I plug it into the TV at the hotel, right? There's a lot of different scenarios that we could put this to, but ultimately it's providing that client to be able to access that remote solution without having that solution physically sit at their desk, right? So it gives us the ability to do different things, and then reducing that data latency, right? If I'm traveling and I'm in Europe and I'm coming back to the US, we want to move as much of that latency for the data portion of it back into the data center. Several years ago, I was doing some work in Sydney and remoting to my machine that was hosted in central Missouri, right? And yes, I was going halfway around the world and accessing that with some fairly high latency, but I'll be honest with you, I would have never known it if I hadn't been in this industry, right? I was able to access my desktop, do my stuff, and it was just fine from a protocol perspective, being able to see things update and all that good stuff, had no issues, right? So as we start to look at that, that starts to change how we deploy equipment out into the field. The last one is using a personal device. Oh, I think that's, maybe I didn't. Hold on just a second, let me back up one. Yep, okay. Using your personal device, I may have bled over into this one there. Being able to take that experience that the user has, the apps and the desktop that they need, and access it from anything, whether that's my iPhone, my Mac OS, maybe I'm at my mom's house where she has a Windows machine. We just bought her a nice new Windows 11 machine for her to play solitaire on, but I need to do, and I am then able to connect remotely to that machine that's in the data center from any device out there, right? And go forward and access my apps, et cetera, but leave very little footprint on that machine as far as data, okay? This is very popular for contractors, right? Call center type things where we're pushing the user home. And then last but not least on that solution, remember all that data is always encrypted from point A to the user. It's never, running in the clear, so we're able to make sure that we're not compromising any data. Pause for a second. Just let me check to see if there's any questions, and hear if there's any questions. If anybody's got a question, please don't be afraid to ask. Quiet group today, must be Friday.
Yeah, Dave, I'm checking the chat window, nothing there. So.
Okay. So last but not least, there was a whole bunch of stuff, and I put this into several slides to just kind of go through it so that we can talk about it, about the defined pillars of what we address, right? So as we start to look at that, right, as I went through this, I wanted to make sure, pretty clear, we are part of a zero trust solution, not the zero trust solution, right? Defense in depth. So as you start to look at what you want to do with zero trust, there's a lot of different things, maybe getting the paths, speeds, and feeds isolated internally from the outside is your first step, right? So you want to make sure that when I'm on the network, I have no business being on HR apps, right? Those HR apps are closed off to me. So you use your zero trust in that scenario. And then, hey, we want to make sure the device that Dave's coming from is protected and secured, and we don't trust it until it has passed our test. So we use the Teradici zero trust to establish that layer of trust from the device into the environment. Okay, so when we start to look at what do we address in the pillars, pretty much our niche is devices, infrastructure, and networks. Okay, making sure the device is secured, that infrastructure path is secured, right? That we don't have to go outside of that, and that the networks that we're accessing are secured, right? As we start to look at how we address the different pillars, right? I kind of covered this, but on the device, minimal attack vectors, right? I don't have an OS that is bloated with all sorts of stuff. We'll just use Windows ROT for an example that has a lot of vulnerabilities, right? We can now say, hey, use this, purpose-built device that has a very small attack vector to, depending on what your trust is, right, to a Windows machine that, has just the client on it, right, so that you can access different things. On the infrastructure, reducing those attack vectors, right, the ability to, trust both internally and externally. And those may be divided into different trusts as you start to look at this from your perspective, right? And then making sure that your ingress and egress are encrypted, right? So all that data that we're sending is encrypted. And apparently I was typing fast and I misspelled traffic, but making sure that traffic is all encrypted so that if somebody does do some poking and prodding on that traffic, they're not getting anything, okay? IoT, it really doesn't matter to us. If you want to build an IoT device from, a client perspective, yes, we can play there. If it's protecting different types of, Internet of Things stuff, we really don't touch into that, okay? Where are some of our operational, right? DoD, big DoD, a lot of DoD, right? Department of Energy uses us a lot for Linux solutions, okay? DHS solves some remote computing needs with us, doing different things. Healthcare, right? If you look at federal DoD healthcare and the VA, there's a lot of zero clients in those spaces because it reduces that data at the edge, right? It gives them the capability. There's a, being able to go from room to room, machine to machine, but not having to have all the apps and data on machine to machine, right? So giving that type of scenario. And even in media and entertainment, on the civilian side, huge, but on the government side, we also have, oddly enough, I didn't realize this until I started doing some of these projects, a lot of media and entertainment, right? Where we're editing training videos, where we're editing marketing videos, hey, here's how, your SSA stuff works, or hey, here's, how we support humanitarian issues, right? So a lot of different areas in media and entertainment where they're using our technology to finalize the editing of basically, commercials, if you want to put it that way, or training videos. So a lot of different things that we do there. Moving on to some more of them. We all know that the zero trust mandate isn't going to happen immediately, right? We don't just flip the switch and now we have a zero trust infrastructure. And from our perspective, it's a transition at your speed, right? So as you start to do things, you can start to implement no zero trust. It's kind of double negative, but no zero trust on the clients to, hey, first thing I want to do is just make sure that the clients that are coming in are trusted, right? So I can make sure that we have a zero trust framework there, and then start to protect internal. You may go the opposite direction. You may set up all your internal protections and then deploy to the client side, right? But ultimately, it's how do you want to do it and how do you want to implement it? And it can be a phased approach with our technology, because you can say, hey, I'm going to take all the contractors and implement zero trust, and it's not an all or not, right? So it gives us the ability to phase that. How do we detect and identify? We don't, right? We leave that to others. Other than on the zero trust framework, we will be able to tell if the device has been tampered with, right? So based on how that certificate and that incorporation of that device, if something's happened to it, we will be able to tell, and it will basically become a dead machine, right? Because we can't trust it anymore, and we will lock it out so that we don't have that compromised machine. But as far as all your other stuff, very little play into that. Use those other tools that will overlay with us and play well with us to establish all that additional protection. As far as end user device compromised, right? How do we change, or how does your solution contain the impact of the exploit, right? As we start to look at small footprints, right? So small attack vector, right? But there's no data there, right? What's the user going to steal, right? A bunch of encrypted cache that's of no good, right? Because it's just random pixels going back and forth. So it starts to reduce the amount of impact that you have. You're not reporting that 21 million records were compromised, right? Because the 21 million records weren't there. So it starts to change how you're containing all that stuff. And then when it comes to updates, right? Let's go with the log4j, right? The update from the outside perspective is, as soon as the security release is released, you deploy that update to those devices, which gives us the capability of moving quickly, right? Versus having to do shift and replace stuff, pull in stuff. There's a lot of complexity sometimes when we're updating from a OS vulnerability that we have to address. So it gives us the ability to address those things fairly quickly. Kind of bleeding into, okay, impact of insider threats, right? Let's hit that. I always encourage my deployments to put the zero clients on what I call an untrusted network, right? And a closed network, right? Imagine we could all be sitting at the table, and I'm going to date myself, with a dumb hub that has one exit to the data center, right? I can't go to the internet, I can't go do this, I can't do that. So by being able to contain those environments, right, the impact from an insider can be reduced, right? If they can't get on the network to other things, we're able to reduce the ability for them to compromise multiple machines, et cetera, right? So it gives us kind of a different protection, right? Let's talk about the SolarWinds stuff. The biggest answer I have to that is we are ATARC compliant. We went through that process for a customer and some stuff that we were doing over on the AWS side, right? So we completed that. Our FIPS validation, TAA compliance, right? All these things that DoD and IC customers always request, and civilian customers always request, right? We have all those basics covered. Pause as I go to the next page for any questions. All right. Interoperability, right? Pretty simple. We provide a remote access to the desktop, right? So all that other stuff to us doesn't matter. So there is no impact to interoperability, right? If you go and deploy, I'll just make up a name, Tiddlywinks Zero Trust Infrastructure Solution for apps, right? That's fine by us, right? You're going to put that onto those virtual or physical images, put those rules in place. All we're providing is remote access to that device. Leveraging, okay, most agencies will have a mixed cloud and traditional data center. How do we work in this hybrid, right? Legacy and cloud, we just do. I preach, one of my things, and we have had problems with this in the past, is capacity management. And as we start to look at capacity management, what we want to do is we want to optimize our environment. We want to optimize our environment to use 100% of our on-prem resources, right? Now we get stuck into a situation where, hey, if I have to account for 10,000 users, how do I build that and provide infrastructure for 10,000 users, right? I can't do that off of one machine. Now, the reality is I may only have 100 users at day 0 or hour 0, but I have to build for that, right? And we oftentimes overbuild. So my approach on this and my recommendation is build for what you think you're going to have on-prem and overflow to off-prem, right? So the example I use for this is KB and I, right? Sorry, I got up and started walking around and forgot that I was on camera. So KB and I work different hours. I'm a morning person. I usually come in first thing in the morning, start doing work, connect to the data center, and off and rolling I go, right? So my machine, nobody else is there, so my machine gets deployed on-prem and I connect on-prem. KB comes in a few hours later, and as he comes in, he logs in and it says, oh, all on-prem resources are utilized. Let me deploy him out in the cloud, right? So we can have that mixed environment without the end user having to make those decisions. Now, I'm not addressing, and we don't address, what are the speeds and feeds that you put in between them and the data paths and all that good stuff. But to be able to, what I call automatically deploy one place and connect, or deploy another place and connect, is something that we can definitely support. Okay. Let's address the investments, right? As far as we're concerned, if you have a Terra 2 zero client, let's just say you were utilizing that to connect to a Horizon View environment, great. You need to do something with that user where they need higher end graphics and you want to do something else, okay, right? Go ahead and utilize that. Point it at the new environment and off and only go. Or maybe you have a user that has a laptop that has, gotten what we call Windows rot. You could reduce that to kind of a dumb access point, install the CAS client so that you can reutilize that GFE equipment and point it at the new infrastructure and go forward. So it gives you a lot of flexibility to do different things, right? Utilizing what you still have, right? So as you do that, it gives you, a path, not where you of flexibility where you don't have to make all decisions all at once. You can go down for one use case and say, hey, these users get reutilized laptops. These other users are doing really high-end stuff. We're going to give them the new laptops with the client on it. It gives you a lot of different aspects. Okay. And then let's see, integrate with a trust algorithm. I don't know if Aaron can come off speaker or off a mute and answer this. I don't have an answer to it. And I wasn't going to answer it, but I'll see if Aaron has an answer to it if he can come off mute.
Let me go have a question. So what was the specific question, Dave?
No worries. How do we integrate with the trust algorithm, right? NIST 800-207.
Yeah, well, we'll take it. So we have some new technology being launched this summer. and we'll have more detailed information coming out publicly in early May in white papers and in blogs.
Got it. So the answer is to be determined. Watch out for stuff in the spring, or further into the spring. So later this year. So as far as that's concerned, I want to open for anybody else that has questions as far as implementation, user experience, anything around the Zero Trust platform that we're looking at and how we're changing what we're doing going forward. And while I do that, I'll just put up contact info if you want to reach out to us. Here's all of our contact info so that you can gain, our feedback directly if you need it, but open up for questions.
Hey, Dave. Doesn't sound like we're, I don't see anything in the chat window. Not sure we're going to get any questions here. I think this is our last slide. Oh, we do have one. So we said, thanks for the presentation. Thank you,
Yes.
William. I guess I would just wrap up here, Dave. I think it's your last slide. Is we appreciate everybody's time. Thank you, ATARC, again, for having us here, giving the invite. Yes, we will definitely share the slide deck. That's something we will do. We'll work with ATARC to provide that out there. We do have some follow-up items. We will. And just stay tuned. As Aaron had mentioned, we got acquired by HPI. So we're kind of closing that gap on the acquisition. Things and products are getting merged together. So there was a little bit of delay, but then there's also things that are coming, and it's going to continue to move forward with our plans for Zero Trust at the Teradici level. So you'll see more to come. Best words is stay tuned and reach out to us if you need anything regarding Teradici and Zero Trust.
Yeah, I can give, if you want, I can give it very quickly in a 1-minute nutshell. But we'll be launching a brand new Zero client with a new Zero Trust architecture and a Trust Center service for any remoting area. So everything that needs to be remoted. All the technology that Dave discussed today with cloud access software, with clients, connections, security gateways, we'll be bringing out a complete new suite of technology around Zero Trust architecture for virtual and remote environments.
And an important part to add to that, and this is as we start to look at stuff, it's not all or one, right? You can go from legacy to next gen and cohabitate those, right? Now, legacy won't be Zero Trust architecture, right? And that framework, but as you start to migrate from one to the other, those can coexist, right? So as you start to look at your path forward, it's about, how do you want to get there? I have always believed that projects were multi-phased in a journey. And as you start to look at that, we give that ability to go through that multi-phase journey, come off a legacy. Maybe let's just say the path is come off of laptops and move into Zero Trust next gen clients, right? Okay, there's a path there, right? Now you don't have to do all the work up front, right? It's not like we're going to say, hey, you got 200,000 users on, hey, today's April Fool's, so use April Fool's. You're going to move all 200,000 users today, right? April Fool's, that ain't happening, right? So as we start to look at that, it gives you that ability to phase it in over time successfully, right? So you take a use case, maybe it's all the contractors, you address that use case, that's your biggest vulnerability, done, right? Next use case is work from home employees, right? You go address that use case, make the migration, done, right? And then you just keep working through the use cases until you get it all completed so that you can have that phased approach, which will mean that, hey, April Fool's, we're moving 200,000 users today, right? You don't want to do that. That's going to cause you problems that you just aren't prepared to address because of all the changes, right? So it gives you that phased approach.
Awesome. Well, I'm going to stop recording now.